Well, now that you've seen the video on how to recognize it's a product rule question and all the worked examples of product rule questions, let's answer a few exam questions. So we've got 4. 2 are pretty nice and cute. One of them, it looks horrible and ugly, but that doesn't matter to us because we've got a magical rule, which is a product rule, right? And once we've got that, everything else just falls into place. So let's answer these questions. It says, given that y equals x cubed minus 2x ln x is this, find dy over dx. Now notice, they will never tell us to figure out that it's a product rule question. And how do you know? Because they're multiplied by each other and there's no way of expanding and getting rid of these x's beforehand. So the rule is differentiate first, leave second, plus leave first, differentiate second. That's simple. So we've got dy over dx. We recognize that this is a product rule question. So differentiate first. If I was just going to differentiate it, I just differentiate normally. X cubed differentiates to 3x squared minus 2x differentiates to 2. So I've differentiated first. Leave second, ln x, plus leave first. So we leave x cubed minus 2x. Differentiate second. When I differentiate ln x, I get 1 over x. And I could just clean it up now. So I end up with 3x squared minus 2 ln x. And then if I'm multiplying by 1 over x, I'm dividing everything by x. Okay, I'll do the long way just in case people aren't too sure about that. So it's the same as having x cubed minus 2x over x. And then I can just write each term divided by x. So it would look like this. It's the same as saying x cubed over x minus 2x over x. And then we can simplify that a bit more. So you get 3x squared minus 2 brackets ln x plus, one of these cancels with these. So I end up with x squared minus, one of these cancel with that, minus 2. That's it. Really lovely and really simple. It does say give your answer in its simplest form. I feel like there isn't a form simpler than this. So I think that's okay. I think that looks good. Anyway, let's look at another one. We'll get a little bit of trig in there. So we've got cos 2x. Let's just remind ourselves, when you differentiate cos x, you get minus sine x. I always have to remember that myself as well. So how do we know it's a product rule question? You've got e to the power of x times cos to the power, times cos 2x, okay? You can't get rid of them, it times that. So we're going to do our product rule formula. So let's differentiate. Differentiate first. When I differentiate e to the power of x, I've got e to the power of x. Leave second, so cos 2x. Plus, hey, where did I go? Plus, leave first, e to the power of x. Differentiate second. So I need to differentiate the second one over here. Now notice, it's not just cos x, it's cos 2x. It's got something inside it. So we're thinking chain rule, okay? The way I do it is I differentiate the outside and then I multiply by the differential of the inside. So how does that look for me? If I differentiate cos 2x, I'll end up with minus sine 2x. So this plus is going to be minus. So minus sine 2x. And when I differentiate the inside, which is just 2x here, if I differentiate 2x, I end up with just 2. So I multiply it by 2. Okay? Now let's clean it up. E to the power of x sine. And if you wanted to factorize out the e to the power of x for whatever reason, you can take e to the power of x because it's common for both of them. And then in brackets, you end up with cos 2x minus 2 sine 2x. Important, but it's a good skill to have because when you come to do identities, you have to manipulate it algebraically. So it's good to keep that in mind. Let's look at another one. Is this the ugly one coming? It is the cutest ugly one you've ever seen in your whole entire life. But yeah, look at this. This is nice. It'll give you practice of a whole load of things. If I see this question in the exam paper, would I even know it's a product rule question? Well, let's see. I've got this whole thing times e to the power of 6 minus x, which means I'm dealing with a product rule question. No matter how it looks, it doesn't matter because we've got the magical rule. Differentiate first, leave second, plus leave first, differentiate second. So let's look at this. I need to remind myself, when you differentiate sine, you get positive cos. When you differentiate cos, you get negative sine. Don't make the minus mistake. Over dx equals. Differentiate first. I'm differentiating this whole thing over here. Okay. If I differentiate this, remember, it's not just sine x and it's not just cos x. You've got something inside, so you're thinking chain rule, okay? So let's differentiate the outside. So if I've got 2 sine 3x, it turns into 2 cos 3x. And if I differentiate the inside, which is 3x, I end up with just 3. So times 3. Same for this one over here. If I differentiate cos 3x, I end up with minus sign, and a minus and minus would make plus sine 3x. Now I differentiate the inside, 3x, which just gives me 3. So I have to multiply it by 3. So we're using chain rule inside. I just pause for a bit. Okay, you can just absorb it. So we differentiated the first. Now we're going to leave the second. Leave the second. E to the power of 6 minus plus. Just following this rule. So let's put plus. Leave first. So we're leaving it. 2 sine 3x minus cos 3x. Differentiate the second. So if I differentiate e to the power of x, I get e to the power of x. But it's not just x, it's got something inside it, so it's chain rule as well. So let's do the outside. If I differentiate e, the e function, I just get e to the power of 6 minus x. Now I need to differentiate the inside. If I differentiated 6 minus x, what would I do? What would I get? 6 would go away. Minus x will be minus 1. So I have to multiply it by minus 1. Where should I put it? Here or there, here or there, here or there. Times minus 1 times e. Okay? Which is going to make that minus. So now let's rewrite it. Yeah? And then I had a minus 1 over here. Let's take it out. So plus or minus is going to be minus power 6 minus x. It sure is a lot of things over there. But you see, it doesn't matter how hard it looks, how weird it looks. You're still just follow the rule. It does say in its simplest form. So let's see if we can simplify it a bit more. If I have a look over here, is there anything common between them? Better be right after all of this. It says to the simplest form. So let's see what we've got in common. So we've got e to the power of 6 minus x in common for sure. So equals e to the power of 6 minus x. Open up our brackets. And we're left with literally everything next to it. So 6 cos 3x plus 3 sine 3x minus, and don't forget the minuses for both of them. So let's put it in brackets. 2 sine 3x. We don't want to do all this hard work and end up losing marks of that part. Because we're geniuses and nothing's going to trick us. And 2 sine 3x minus cos 3x. Close your brackets, and then we're just going to make it positive. So equal e to the 6 minus x. It's minus 2 sine 3x. And then plus cos 3x. Okay. Can we simplify this more? Oh, yes, we can. So let's do that. So we've got e to the power of 6 minus x. And then let's put the causes together, the signs together, okay? Remember, because it's cos 3x and this is cos 3x and cos 3x, don't even think about it. Don't. So 6 cos 3x plus cos 3x is, it's like 6 of that plus 1 of that, so 7 cos 3x. And here you've got 3 sine 3x minus 2 sine 3x. 3 minus 2 is 1, so plus sine 3x. Let's decorate this. That's a lot of time of our lives. This question better be at least 5 marks. Okay, so the actual differentiation part falls into 3 parts. First of all, recognizing its product rule. Secondly, knowing your chain rule and all that jazz. Thirdly, after you've differentiated it, it's just algebra that you would have done in GCSEs or before. Okay, so just bear that in mind. Everything else is algebra. Once I've done this new part, which is product rule and differentiation, everything else is algebra. I called it the cutest ugly to make ugly not sound too ugly question, so you kind of see the beauty of it because it's absolutely beautiful. Look at that. Look at the piece of work. Screenshot. So let's go for a bright orange. So you've got y equals this. How do you know it's a product rule? We know now because it times that and you can't get rid of the x's. Let's differentiate this. So we end up with dy over dx. Differentiate first. Let's differentiate this. Oh, Baba, this even has a chain rule. I didn't spot that squared first. Okay, so differentiate this. Chain rule, differentiate the outside and multiply it by the differential of the inside. So the outside is something squared, okay? I just ignore whatever's there. So it's going to be 2, because I multiply by the power, take 1 away from the power. 2, and I take 1 away from the power, so it's 1. Whatever's inside goes the same, x squared minus x. Okay, chain rule. So I did the outside, I'm going to do the inside. If I differentiate x squared minus x, I end up with 2 x minus 1, because I've got x squared, so that becomes 2x, and then the x becomes minus 1. Okay, so I've differentiated the first. Leave the second. So ln 5x. Simplify that later. Plus, leave first. Thank God. Don't want to differentiate that again. X squared minus x all squared. Differentiate second. Now, when I come to differentiate this ln x, it's not just ln x, ln 5x. So you're thinking chain rule. Same thing. If I were to differentiate ln generally, it will be 1 over the x, all right? So if I differentiate this, it's going to be 1 over 5x. Now, if I differentiate it inside 5x, what do I end up with? 5. So times 5. And then they'll cancel over there. Now we've done it. What are we going to do? Clean it up. Let's go. So dy over dx equals, we can multiply. Oh, we can do a lot with that, can't we? What's to the power of 1, so we could just expand it. Okay, so 2x squared minus, what's that? Minus 2x times, remember, because there's brackets, 2x minus 1, and then 5x plus, let's rewrite that. We know this will cancel out, so it's 1 over x. So 1 over x squared minus x all squared. Now, the algebra. Let's expand. I might just fast forward this part. And then 5x plus becomes x squared minus x times x squared minus x. Let's do that as well. All divided by x. Don't forget that. We should put it over there. So x squared times x squared is x to the power of 4. So we end up with, and our final answer is plus x cubed minus 2 squared plus x. Is there anything else I could do with any of these? No. Let's check. X cubed minus 2x squared plus x, and I thought x cubed minus 6x squared. It's just decorate the final one. What color do you guys want? Can't tell me because you're not with me. Let's go for blue, because light blue and orange look so good together. So, and that's it, folks. That's all of it. So product rule, it doesn't matter how weird the question is, but something you do need to know. You need to for sure, before you get into product rules, you don't find it so meaty, you need to be super confident with chain rule, with differentiating exponentials and ln's and trigonometry. Okay. But if you are very confident with chain rule, differentiating all of that is really simple, because you just have to remember e to the power of x differentiates to e to the power of x. ln x differentiates to 1 over x. Sine differentiates to cos. Cos differentiates to negative sine. Tan differentiates to x squared x, right? So if you remember that, you just need to get really, really confident with the chain rule. Hopefully, inshallah, I'll make a chain rule video soon. Just so slow, it takes. Anyways, so I hope you found that helpful, and I hope you love product rule now. X minus 2 e to the power of x. What did I do? Did that wrong? Okay. Should be thinking about x's now. We can think about education. Shouldn't have x's. Just go and watch cartoons. Anyways, then there's a 3 there. I don't know what happened to me there. I just ran away. Anyways,